you have to, whenever we are starting anything, right? This entire system is going to be set up for the first time. So before creating the load balancer and everything, what do we need, guys? What should we create first? We have to create the VPCs, right? When we create the VPC and the subnets, that is when we can place our entire infrastructure that we are building on that. Okay, so we need our own network first in the cloud. Only then we can create anything else. Okay, so we need the VPC first. So let's come here. I'm on in this region. I'm in the Tokyo region. So my advice to you guys is, because I keep doing different things, guys. Okay, one region and certain demonstrations where you need two regions like VPC peering we did yesterday. Those cases, just maximum reach, use two different regions. So if you are practicing something new, just delete whatever you have created, then practice that in the same region. Okay, because that helps you to follow up, or else you'll create some things, you'll leave it running, and then there will be unnecessary builds. So make sure you continue to use the same region every time. So now here in this case, I'm going to create a VPC. Okay, so now on the left hand side, I go for VPC. So we don't have any VPC in this region. So this is the default one. So I create my own VPC. So I can just call it something like Tokyo VPC. Here I'll take the range as 192.168.0.0/16. That's it, and I create the VPC. Okay, now let's create the subnet. So what we are going to do is this three servers that we are creating, we are going to make sure that they are placed in three different availability zones. So even if they are one is failing or something, the others will continue to run. If I keep all three in the same availability zone, if the availability zone fails, that means if the data center fails, all three of our servers will go down. So we don't want that kind of a scenario. So we're going to keep them in separate availability zones. Okay, so if I want three servers, guys, how many subnets will I have to create if I want everything in the different subnets in different availability zones? Will require three, correct? So I go to subnets. So we're going to create three subnets now. All three can be created together. So I say create subnet. So I select the VPC. Okay, so I'm going to call this my, so I'm going to call this my public subnet 1. Okay, public subnet 1. Availability zones, out of the three, we are creating one. So understand one thing, guys. What are we doing? The availability zone is a physical data center. Okay, so I'm saying, and the subnet that we are creating is just a logical boundary. So we are saying first subnet I want to keep in first data center. Second subnet I want to keep in second data center. Third subnet I want to keep in third data center. In case one data center fails, that means one availability zone fails, only that subnet will be impacted, and only the server in that subnet will be impacted. Other two will continue to work. That's why we are placing first subnet in the first availability zone, and the CIDR is 192.168.1.0/24. Okay, and I'm going to add more here itself. So I'm saying add one more. This will be my public subnet 2. This will be in availability zone. Can I select one, whatever the second one, right? And then my subnet CIDR will be 192.168.2.0/24. Okay, so this is 192.168.1.0, 192.168.2.0. Let's take one more. Say public subnet 3, availability zone third one, 192.168.3.0/24. That's it, guys. So three different subnets we are creating now. So in this VPC, we have created three subnets so that all three of our servers can be kept in them. So it really depends on how many servers you want. So it doesn't mean, guys, that if you want 6 servers, you need to create 6 subnets. No. If you have 6 servers, you'll create the same 3 subnets, and then you'll place 2 servers in each subnet. So we have only 3 availability zones, right? So you cannot create any more than that. So let's go ahead now and come down. I click on create subnet. So all 3 of our subnets have been created. So once the subnets have been created, will these serve, these subnets, are they immediately connected to the
हेलो जी Gracie, I call you back here. अभी right now I'm in a meeting.
internet, or what should we do? Because we do have web servers coming up, right? So they need to be accessible from the internet, correct? So we need an internet gateway. So the subnets will be in a VPC, and I need to give an internet gateway connection to that. Okay, so I go to internet gateway and I create an internet gateway. So Tokyo IGW, create internet gateway. Okay, go to route table. Internet gateway, let me just attach it to the VPC. Go to the route table. Now there is a small change here, guys. Can you tell me how many route tables will I need? So the answer is, guys, it's just one. Why? When we were creating two different subnets, we were creating two different route tables. What was the reason? Because the routing requirements for both those subnets were different. One subnet was public subnet, so we needed a route table. Another was private subnet, which had to go through NAT, so it had a different routing requirement, right? So that's why we created the second route table. But here, all three of them are public servers, right? All three of them are public subnets. So we use the same route table for all three of them. Okay, because none of them are private subnets, all three are public subnets. Okay, so let's say I create a public route table. I select the VPC and I click on create route table. Okay, so as soon as we create a route table, there are two things that we need to do. I click on subnet associations. Okay, and I have to edit the subnet association. And this route table is going to be associated with multiple subnets, all three of them. So I just select all three. So all three of them will be connected now to the internet gateway and able to access the internet. So click on save changes. So if you see here, all three will be shown. Okay, now let's go to the route. I have to add a route for the internet. So I say edit routes. Gateway. Click on save changes. Okay, so now that it is created, guys, we have created the subnets, we have created the internet gateway. Now let's move to creating the servers. Okay, so we have to create three servers and we have to configure web servers on them. Okay, so I'm going to get into instances, launch instance, public server, say Windows, streaming st2.micro key pair. I can either create a new one or something. Don't have the previous ones because yesterday we were not using this one, right? So I say key. Okay, so key is also done. Now network, the first server that I'm creating, I have to put that in the first subnet. Okay, so I click on edit. I select the VPC and I put it in the first subnet, public subnet 1. And should the auto assign public IP be enabled or disabled, guys? Correct, because this is a public server, so it should be enabled, right? So we will keep it enabled for all three servers because all three are public. So that's it. Now I create one security group, just calling it LB for load balancer. That's it. So I'm going to allow RDP. I'm going to allow HTTP. That's all we need. Okay. So you see, guys, what did we do? We have created the server. So we put the name in server. So this is the regular way that we create the server. Okay. So we create the servers first, then we add it to the load balancer. So we have selected the VPC, subnet, etc. Now click on launch instance. So the first server is ready, guys. So we are going in this sequence. We are creating the server one by one. Okay, so we'll create the server one by one and place them. So let's create the second one. Call this my public server to select this key pair. Select this VPC subnet 2. I'm going to place it in subnet 2. Auto assign public IP will be enabled. Select the security group. Storage. That's it. Now click on launch instance. Okay, so second one is also created. Let's create the third one. Okay, so this is it. So we're creating three servers, guys, and placing them in different subnets within the VPC. So this will be in public subnet 3. Our signed public IP will be enabled. And that's it. So our third server is also ready. Okay, so now guys, we have created all the three servers. We will create the load balancer and target group everything. But first, we have to configure the servers as web servers. Okay, so we'll do that. We'll configure the servers as web servers, and then we will go ahead and create the load balancer. Okay, so we'll quickly go ahead and connect to the servers first. So exactly the same way, guys, we configured the web server. We are going to do this, right? So understand one thing, guys. If I want, honestly, I'm telling you, because there are people with different experience levels, that's why I'm going through this. I can very quickly, with just one or two commands, quickly create a web server and show that to you, right? But purposely, I'm just going through the manual steps so that you understand how things are happening in the backend. Okay, so that's why I'm going through the manual steps, creating the web servers and creating the load balance, everything manually. Once this is done, I will also show you an automated way of how to do things. Today we are doing it with Windows servers. The further demonstration, we will switch completely to Linux servers, right? So this, I'm showing the manual process of how to do things, and then I will show you with Linux servers how you can set up the entire same thing with very quickly with certain scripts and with Linux servers, right? So here we are just logging into the server. So first server we are logging into. So the first server, the IP address is 18.183.241.170. Okay, so 18.183.241.170. So this is our first server we have logged into. Let's log into the second server. Okay, so I'm connecting to the second one, RDP client. Okay, so both the servers are loading up. The third one also we will connect. Okay, so all three servers are now loading. Very quickly, I just want to open up the server manager on all three. Okay, because that is what we will use to configure our web server. Okay, so on all three, server manager is coming up. Now, so let's configure the web servers first, guys, and then quickly we'll move ahead. So this is our first server. Here, I'll just quickly go. So this is the server manager. So we had seen this earlier as well, guys. You just go into server manager. You go to add roles and features. So there are plenty of things you can add from here, but we are interested only in a few things. We are only interested majorly in the web server, IIS. So I say next here. So you see here web server IIS, you just select that one, add feature, you won't select anything else at present. Keep clicking on next and we click on install. Okay, so once this is completed, when the installation is completed, we know that the folder called as inet pub will come up here, right? In the C drive, we will have the folder called inet pub, and into that, we'll just go ahead and create the root index file. Okay, so let's do that in the other servers as well. Go to add roles and features. Okay, so similarly here also that folder will come up. We'll just keep that open. So once that comes up, guys, then we will be able to access this particular server's public IP and check whether they are configured properly or not. Okay, so I come to the third one. Okay, so add roles and features. Okay, so we have enabled it on all three. Let's go to the first one and create the file. Okay, so I'm coming to the first one. So this is our inet folder. So I come here. In the root folder, I just create a file. Okay, and I'm going to say this is this is all I'm going to say. This is just to identify which server we are connecting to. Okay, server one. So I save that as index.html and I save it as all files. Index.html, all files. Click on save. Okay. So now that we've done that, guys, if I go to the first server's IP. Host server's public IP, if I check it, we should be able to access that. Okay, so you see, this is server one. This server is publicly available now. So let's do that with the second and third one also quickly. So I go to the C drive to hub root, create a new file. Say this is server 2 and I save it as well. Index.html and I save it as all files. Okay, so this is also done with. Okay, I'm going to do the same with the third server now. So I'm going to root. This is server 3 index.html. Files and I save it. Now that we've done all the server related, now let's move to the load balancer. Okay, so all three of this is done. Now let's move to the load balancer. So where is the load balancer? On the left hand side, guys, in the VPC page, you see on the VPC page on the left hand side, I think it's on the server page itself. On the instance page itself, I think if you scroll down, you'll see this load balancing. On the instances page itself, if you come down, you'll see this load balancing. Right, so let's click on load balancer. There are majorly two types of load balancers, guys: application load balancer and network load balancer. They work exactly the same. Everything we are doing remains the same. It's just that the ports are different. Okay, so in application load balancer, we use the HTTP port, that is the internet port, and in network balancer, we use the TCP UDP ports. Okay, so it's exactly the same. We'll see the second one also later on in the one of the demos where we do multiple services together. We'll see that gateway load balancer is not part of our curriculum. So we'll see how the application load balancer works. So I put the load balancer name as let's say Tokyo load balancer. Now there are two types of you can have two different implementations of a load balancer. First is internet facing, where you are using that load balancer for balancing the load among internet-based websites. Okay, so where you are getting users from the internet. At the same time, it can also be used for internal websites. Let's say that there are certain organizations which have certain websites running internally for their own employees. Websites like their attendance page or their own internal intranet pages where they can manage their leaves and all that, right? So those are also called as intranet-based sites. They're called as internal sites. So they can even use the load balancer for that. Okay, but we are looking at internet-facing. So I select internet-facing. I come down, and now if you see, guys, here we are in the process of creating the load balancer, guys. So we give it a name. We select internet-facing. Come here, and I select the VPC. Correct. So we select the VPC. Now, when I select the VPC, guys, if you see, it automatically shows me the three different availability zones that are in this VPC. Now it is asking me which of these availability zones under your VPC do you want to use for load balancer. In earlier itself, we have created our servers in all three of the availability zones, right? So yes, of course, we want to use all three, but the condition is you should use at least two availability zones for your load balancer. If you put all your servers in just one availability zone in one subnet and you say I want to use load balancer, that's not possible at all. If you see here, it says select at least two availability zones and one subnet per zone. So that's what we have done. We have selected one subnet per zone, but we have used three availability zones, right? So we will select all three. I want to use all three for my load balancer. As soon as I select the availability zone, you see it shows the subnet which is available in that availability zone, which we have created. So I can even have multiple subnets in each availability zone, right? I can select multiple subnets also. So that's it. Now I come down. So security group, you see it is showing the default one. I don't want that. I want the load balancer. So I select that one. So in load balancer, we have allowed HTTP also. The default one, HTTP will not be allowed. So using this one. Now, if you come here, guys, this is where our real routing happens. So you see there's something called as a listener. So what is a listener? Very simple process. A listener is a software-based process which sends any request which comes to the server on port 80. What is port 80? HTTP. That means internet. That is, whichever request for the internet comes to the load balancer, this listener, it's just a process, that listener picks up that request and it sends it to where target group, right? So that is what we discussed here, target group, but we have not yet created the target group, right? So that's why if you see, there are no target groups mentioned here. See here, there are no target groups. Why? We have not yet created it. So it says load balancer cannot directly send the request to a server. Okay, it never interacts with the server directly. It sends it to the target group. Inside the target group, there are servers. So it says if you don't have a target group, create a target. So when I click on this create target group, it will open up in a new tab. We will create this target group and then we will come back to this same procedure here and then we'll continue. Okay, so I click on this create target group. So it opens up this page. Okay, so it is saying, okay, you want to create your target group. What do you want to add to your target group? You can add it through instances or IP addresses or Lambda functions and all, which we can see later on. Right now, we are interested in instances. So to my target group, I want to add instances. So I just select that. I give it any name, Tokyo, and which VPC is it going to be associated with? So we have the Tokyo VPC already selected. And then there is something called as health check, which when we have created the target group, I'll explain in detail. So that's it. Now we are done. So what all have we done? We said that I want to add instances, nothing else. I want to give the name Tokyo, this one. I select the VPC. That's it. Okay, so now I click on next and it is saying, okay, you want to add instances. Which of these instances do you want to add? So I could have even 10 instances. I could have even 15, 20 instances. Out of that many instances, which one do I want to add? I can select that, right? But here I have only 3 instances. So I select all. I want to add all 3. And you see, it is asking me to add them pending, right? So if you see, when I have added it, it shows running, servers are running, but it will show as pending. Okay, it shows the servers are running, but adding to the target group is pending. Why? Because we have not yet created the target group. So I click on create target group and now the target group is being created. See here, successfully created the target group. So that's it. Now, once the target group has been created, guys, you see here there is something called as a health check, right? Under health check, it shows there are 3 total targets. That means 3 servers. Out of that, 0 are healthy and 0 are unhealthy and 3 are unused. So what is the meaning? It means that although the targets have been added to the target group, yet we have not added them to the load balancer. Correct? We have not yet added them to the load balancer. We have only connected it to the target group. If you see here, you'll understand they are connected to the target group now, but this connection to the load balancer has not yet happened. That's why they are called as unused. So now, as soon as we go back to the previous page and I add it to the load balancer, what will happen is it will do some checks. Okay, it will do some checks on the server. And if this port is reachable on the server, then this unused will become healthy. Okay, so any server which is working properly as a web server is marked as healthy, right? If we had not associated, if we had not allowed port HTTP, right, then it will be marked as unhealthy because it is not capable of functioning as a web server, right? So because port 80 we have allowed in the security group, it will be marked as healthy. If it is not, internet is not allowed, then it will be marked as unhealthy, right? Right now it is unused. So now our target group is created, guys. What do? I close this and I come to the previous page, right? The page where we were creating the load balancer, right? So here, earlier, if you see, we were not able to see any target groups. Now what do? I just refresh this and I will be able to see this new target group that we have created. Okay, so I select this target group. That means now to my load balancer, whatever internet-based requests come in, that will be sent to this one. Okay, so once we have done this, guys, I scroll down and you don't have to do all this. This is something we will learn later on in the security module, how the web application firewall and all works, right? That's it. So now what did we do, guys, for the load balancer? We gave the load balancer a name. We selected internet facing. We selected the VPC. We selected the subnets. Okay, we selected the security group. The listener, we created the target group here itself and we forwarded the traffic coming to the load balancer to the target group. That's it. And now we are going to create the load balancer. Okay. So if you see right now, there was no load balancer. Now if I click on load balancer, you'll see it says successfully created the load balancer. Now this status is still provisioning. Okay. But when I come down, you'll see that, see, my listener rule is any traffic that comes for the internet will be forwarded to this target group, right? This is the target group. So if I open this target group, you'll see that it will be checking, it will be doing the health checks. Health status initial. That means for these three servers, the load balancer is now checking whether these servers are, healthy or not. So what it will do is it will just send some messages in the port 80 and it will wait for the servers to reply. When the servers reply, it will know that, okay, these servers are healthy. Okay, so it will mark them as healthy. If the port 80 is not replying, then it will mark them as unhealthy. So right now, it is still doing the initial health check. So what it does is, guys, continuously it will keep on communicating with the servers on a regular basis to check whether the servers are functioning properly or not. If at any point, if one of the server is unhealthy, then if at any point the server is unhealthy, then it will immediately mark it as unhealthy and it will not send any users to that particular server. It will distribute the users to the other servers. So that's why, for our example, we have kept just 3 servers, but in the real world, there will be 15, 20, 30, 40 servers also. So if 1 or 2 servers are failing, it will not impact the performance much. Then the administrator can check the logs. The administrator sees, okay, 1 or 2 servers have failed. They can go in and replace them when needed. But as such, if you see, the target registration is in progress. So the targets are being registered right now. This load balancer takes some time to provision. So this will also be provisioning. See here, let me refresh it once. So it is still provisioning. Only when this becomes active, right? This is the load balancer. Only when this becomes active will we be able to send traffic to the servers and the servers will become. Okay. So if you see, the load balancer is now active, that means we will be able to check the health status also. So if I refresh this, you see here, all 3 servers are showing us healthy. The load balancer was checking the servers. All the servers reported that they are able to communicate on port 80, and now they are all in a healthy status. Okay, so this is how the load balancer checks and make sure that everything is fine. Now, how do we check, guys, the load balancer is working or not? So what have we done? We created the target group. We have added the targets to the target group. We have added the target group to the load balancer also. Now, the user needs to connect to the load balancer. So how will we do that? So usually for the server, how did we connect? For the server, we connected to the public IP address. But in the load balancer, we will not have any IP address, right? The load balancer has something called as a DNS URL. Okay, URL. It has a DNS URL or a link. So if I just show that to you, you see here, guys, when I scroll down, see here, DNS name. So what is this DNS name? I just copy this, guys. This is the URL through which you can connect to the load balancer. So now what I will do is, guys, I can, with that URL, when I put that in the browser, I will be directed to this particular load balancer. Okay. And this load balancer will then send me to any one of the servers. Now, let's say any one of you connects, second person is connecting, that second person will be sent to the second server, third person will be sent to third server, fourth will be sent to first server again. So on and so forth. So when it is doing this, it's in a round robin fashion. When it is sending the users one by one to each available server, after a certain point, you will see that here there will be 100 users, here there will be 100 users, here there will be 100 users. So it has balanced the incoming load among the available 3 servers rather than just everything going to one. So load balancer is doing that. User doesn't have to do anything. Server doesn't have to do anything. Load balancer balances the load, incoming load. That means the user incoming, it balances it among the available servers, right? So let's see that. How will it happen? I'm showing that to you. So if I copy this, come here and I put that here, you see, it takes me to one of the servers. Okay, it will take me to any one of the servers. So this is server number 2. So right now, so we configured it, right? The servers. That's why I purposely configured the server names separately. So right now I'm connected to server 2. If I refresh this page, you see now I'm connected to server 3. If I refresh it again, I'm connected to 2, 1, 3, 2, 1, 3, 2, 1, 3, 2, 1. Similarly, guys, all of you will also connect to different servers when we are doing that. So we are going through different servers. We created 3 servers, but the load balancer is balancing it. We are not doing anything. Here we are just directly connecting to it, and the load balancer is balancing us between the available 3 servers. Similarly, if you have 10 servers, 15 servers, 100 servers also, the load balancer will balance you. Now, if you see, guys, here when I'm refreshing it, it says server 1, server 2, server 3. Why? Because we have named it like that so that we can identify which server we are connecting to, right? But in the real world scenario, it's not like that. In the real world scenario, all 3 servers, you will have the exact same content, right? So that's completely up to how the web hosting team does it. So that's not our part. Our part is to understand how the infrastructure works, how the load balancer is working, how the server is working, right? So the web team, they will put the exact same content in all the 3 servers. So when they put the exact same content on all 3 servers, what happens? Even if you're refreshing, even if the different users are connecting to different servers, they will get the exact same content. So the users will never come to know which server they are connecting to or how many servers there are. They will never be able to identify. This is just for our understanding. Server 1, server 2, server 3, right? So the users will see the same content in all the servers. So now, many times what happens is right now, guys, when I'm refreshing it, you see, when you are also refreshing it, we get connected to different servers, right? So this could be a disadvantage at times. Let's say that I'm going through a transaction, I'm booking a flight ticket or something, right? And at that time, if from one server, if I get connected to another server, the session is broken. So let's say that I'm making some payment or something, and if I switch from one server to another, that session is broken and my payment could be at fault, that can fail or something like that. So I don't want that scenario. So what do? We always make sure that the certain user who is connecting to a particular server, they will continue to be connected to that server only, right? Even if there are 100 servers, if I am connected to server number 3, from start to end, I will continue to be connected to server 3 only, right? How do we do that? For that, you need to make sure you are going through this target group, and here you will have something called as attributes. Okay, so under the target group, you have attributes. Here, you see here, stickiness is off. Okay, stickiness is off. So you just go to edit, okay, and you just turn on the stickiness. Okay, you turn on the stickiness, and now you will see that based on certain cookies. You must have seen, right? Many websites, when you go, you see cookies, right? So there are certain cookies which are used to ensure that the same user is always connected to the same server. Now, if you see, guys, it will take some time, maybe around 30, 40 seconds. So even now it is changing, but after that, in some time, it will just take me to one server and it will stick to that server. It will not change. So now I think it is done. If I refresh this, see, I'm stuck to server 3. I'm not moving at all. Okay, so this is called as stickiness. This is to ensure that whatever processes or whatever transactions or something you're doing on certain server, it will not get interrupted or you will not face any failures. So this is how you make sure that even if there are several servers, right, the users are being balanced. So if there are 100 users connecting, in each server, there will be equal number of users. But if you have connected to one server, it will make sure that you continue to stay on that server itself so that there are no issues in terms of your connectivity or whatever you're doing in terms of your session. Now, same way, if I remove the thing, guys, if I remove the stickiness, you'll see that immediately if I remove the stickiness, it will immediately, after a few seconds, it will start moving to different servers. So stickiness is the way we always keep enabled so that users are stuck to the same. So yeah, so now it will change. I've removed the stickiness, right? So now it will change. That's why stickiness is important. Whenever you want, you can, you will be connected to the same. Okay, so I have removed stickiness now. So you see, guys, this is the way that load balancers are used. But if you see, guys, this
एंड फ्रेंड इस तरह से लोड बैलेंसर काम करता है। और सपोज